So let's take things that we've learned in the last podcast and apply them here. Now, remember, we're going to be given an f of x here and a g of x here. Great. We're going to put g of x into f of x, right? So I'm going to take this guy here and I'm going to insert them into this spot here. That's great. But I also want to figure out the domain and range of this. So why don't we figure out what some of the restrictions might be on this before we even get started and let that help us and let that guide us. Well, first things I'm going to do is let's draw f of x. Now, remember what a f of x is. It's a parabola, x squared plus 1. So that means it's going to start right here, and it's going to give you something like this. Know your math 20. Okay? There's your g of x, which is going to have a restriction. G of x means x minus 1. It's got to be greater than or equal to 0. Bring the x over. It's got to be greater or equal to positive 1. So it's going to start off here at 1, and it's going to go this way. So I like determining the domain right off the bat. You know and I know there's nothing out here for one of the graphs. So my domain, I bet you, is going to start right there at 1. So I have a feeling that x has to be greater than or equal to 1 based on this restriction here. But how about the range? Are we going to look at the fact that this starts here at 0? Or are we going to look at the fact that it starts here at 1? Which one of those numbers comes into play? That's one of the reasons why it said in the notes previous here, always try to do the domains by visually looking at it and figuring it out. But the range is from the graph. Okay, so let's figure out what this looks like. First off, let's do the algebra. We're taking g of x, this guy right here, we're popping it in here. So this is f of the square root of x minus 1, correct? Okay, f of x is this, bracket, squared, plus 1. Let's insert this guy right in there. X minus 1, there it is. Square of that, well, that's easy. That's just going to give us x minus 1. That's this guy, plus 1. Look, those cancel out to just give you x. Well, wait a second. What does the graph of that look like? The graph of that looks like y equals to x is just a plain old line, 45-degree angle, right smack through the origin. But is this going to be one of those graphs because of this restriction that starts at 1 right here? It just kind of goes out that way? Possibly, but I wonder what the range is. So this is where, again, using your calculator and knowing how to do this is going to be very easy. What I'm going to say is I'm going to take this f of x, I'm going to make it y1. I'm going to take the g of x, make it y2. So this now transposes into y1 and y2 like that. So that's what I'm going to put on my calculator right here, y1, y2. So here we go. Let's check this out. Bring up the calculator. I'm going to put my y1, which is my x squared, plus 1. I'm going to put my y2 here, which is the square root of x minus 1. I'm going to pop that in there. Then I'm going to say, okay, it was y1. Go back and check. It was y1 and y2 like that. Okay, so y1, alpha, f4, y1, bracket, alpha, f4, y2. You're putting y1 into y2. Graph it. Let's see what it looks like. And look, there's that line that I mentioned to you. Look at that. It goes right through here. But look at the restriction. Look at the possible restriction you might have here. Look at this. Right there. It looks like it's at 1. Your range actually starts at 1. Prove it. How would you prove this? Well, real easy. Go second table. Take a look. There's your table right here. Look, all errors until you get to, guess what? 1, 2. Okay? So your restriction then is, of course, look, right there, domain and range. It's very straightforward. So the range then, well, let's do the domain first. Domain is as we predicted, x such that x has to be greater or equal to 1. X is an element of R. Okay, but what about the range? Range was in fact based on that guy. Wasn't that interesting? Y such that y has to be greater than or equal to positive 1. Y is an element of R. Interesting stuff, isn't it? Okay, so let's do the opposite now. Let's do the opposite of this guy. and let's flip it. Let's do it for this and figure out what the domains and ranges are for that. Well, if we wanted to do that, that's really straightforward. Let's do the g of f of x, and let's throw it in there. And you're going to see we're going to get a really kind of an interesting looking algebraic expression. So think about this. This is g of f of x. F of x, remember, is x squared plus 1. Now, think of this now. G of f of x. G was the square root. This is where the f of x is going to go, okay, minus 1, right? So you're going to take this guy right here, and you're going to pop him into there. So this becomes the square root of x squared plus 1 minus 1. Combine that, you got the square root. Oh, those cancel out again. Square root of x. What? What? Square root of x squared is just plain old x. Interesting, interesting, interesting. So let's actually do this graphically. Let's put it into our calculator. So I still have the calculator here from the last time we did this question, but now we have to reverse things. Well, you know what? I'm just going to clear it. It's always good practice. I'm going to go alpha F4, but now I want Y2 as my 1, and I'm going to put bracket. I'm going to go alpha F4, and I'm going to put my Y1 in. There we go. And let's graph this. Let's see what we get. Isn't that interesting? We got some sort of absolute value function. Huh? How is that possible? I'll show you how it's possible. It's actually kind of neat. Remember, in order to square root something, something's got to be positive. But also this, check this out. This is the coolest thing. Doesn't that make everything positive? Even if you've got negative numbers like -2, think about it. Put a -2 in there, becomes a positive 4. Square root it, it becomes 2. Isn't that interesting? So any number here can be negative, but guess what? By squaring it, makes it a positive. By square rooting it, gives you the number right back. So this doesn't tell you a whole heck of a lot other than, check this out. It tells you this. There's y equals x right there, but it doesn't tell you that value. Strange that this does not have a domain restriction. That's really, really quite bizarre, right? But if you think about it, the domain can be anything because, of course, you're scoring it first. You're making it into a positive. So you're actually starting and staying in this area here. Quite bizarre to kind of wrap your brain around that, isn't it? Okay, so let's write our domains and ranges here. In this case, our domain can be anything. All values of x such that x can be any value of r. Wow, is that ever freaky? Look at your range then. Your range is all values of y. Think about it. Look what you had on your graph. All values of y that are bigger than 0. Huh. Okay, so all values of y that are greater than or equal to 0, and y is an element of r as well. This is the reason why we graph things. This is the reason why we have to know how to do that VARS stuff so that we can see the resulting graph and make the right decisions on domains and ranges.